right? So then we move on to the next section. I think we finished with these lines of code. So we'll just start way up here because we're writing functions and we want to write them on top of the void name visibility function we'll be running. For you guys, you will be writing your functions above the int main function, right? So let's move ahead. So today we'll be looking at what namespaces. Now we can see this keyword used over here and we'll see its real use in a bit. We'll see what it provides and the capabilities it provides us to be able to override certain limitations that certain functions will have. So we have looked at overloading in the previous video, right? So let me just quickly clear this comment and then let's see what this code provides. We have looked at overloading in the previous video, sorry. And how do we use overloading? Overloading allows us to use functions with the same name, right? Functions with the same name, but then they perform different functionality. So over here we have an addition function and an addition function. So with the overloading, what overloading allows us to do is that it allows us functionality. It allows us to use the same name for different functions. That's what overloading allows us to do. Provided, and it only comes under two conditions, provided that the number of parameters is different. So we have two parameters here and we have two parameters here. Provided that the number of parameters are different and provided the number of parameters are different, or I should use or because if I use and, then that means both have to be true. But in this case, if either of them is true, then we can use overloading. So I will repeat that statement again. We can use overloading under two conditions. The first is that the number of parameters of the functions is different, or the data types of at least one of the parameters is different, right? So this is what I mean. That might be abstract, so this is what I mean. So we have int a here and int b here, and we have int a double b. So we can see that at least one data type was different. So under this context, we can use overloading. So let's just run this code without printing anything to see if an error will be thrown. If an error is not thrown, then that means that we can go ahead. And to really see the functionality of overloading, I would advise you visit the previous video. So we have seen no error, so we can go ahead. That means we can use overloading. There's no problem. Now the second condition is that the number of parameters is different. So I'll clear. So we have two parameters here, and we have just one parameter here. And I'll clear this b here so that we don't have to run into an error, right? So now we have functions of the same name over here, but with different return parameters. Let's run this and see if overloading will work. And we get the code executed without any error. So it was run without any error, right? So we can see that with this, we are good to go. Now, what if the parameters are the same? So we have int a and we have int b over here. Let's run this and see if an error will be thrown. And we have an error thrown here that ambiguating new declaration of double addition and all of that. So but we can see that we have the return type as integer over here, but over here we have double, but under the same name. So why can't we use overloading? As I have said, we can only use overloading if the number of parameters is different, or at least one data type of one of the parameters is different, and we have looked at those two conditions already. So in this case, the parameters are equal, the number of parameters are equal, and they have the same data type. So we can't use overloading over here. It will throw an error that we are ambiguating the declaration of addition over here, right? So now this is what namespace will provide. Namespace would allow us to override that limitation. So we can use the same parameters, same number of parameters, and same data type of the parameters, and yet it will allow us to override that limitation. So how then do we do it? So this is how to apply namespace. All you have to do is to declare the keyword namespace, and then you give a name to that particular namespace that you want, and then you input whatever line of code that you have over there. want to put under that namespace. So let's look at the application. So what we have to do is to declare namespace first, and then we want to call this namespace add1. That's what we want to call it. And then after that, we input whatever we want inside this two curly brackets. So I'll just cut all this and then put it in here. Right. So in this case, we have namespace called add1. So you declare the keyword namespace, you give a name, an identifier to that particular namespace that you have created, and then you enclose whatever that you want, a block of code inside that namespace, such that when you call the name add1, then you'll be referring to every entity under this block. Right. So we create a second namespace and want to name it add2. Right. Then we open two curly brackets and we cut all this and paste it in there like this. Right. So we have created two namespaces, add1 and add2. Right. So then how do we access these entities that we have just grouped as add1 and add2? In order to access these entities, so you can, and these ones will be called inside our, you'll call it inside your main function, but I'll be calling it inside my void function. So I'll just create space here, that, let me clear this space and then come over here and use enter. Right. So I'll be calling my functions under the void name visibility, and you'll be calling yours under your main. So we have created two namespaces over here, add1 and add2. So how do we access these blocks of code or whatever we have put under it? So how you can do that is by using the name of the namespace and want to say add1 with two semicolons, and automatically we have addition over here. So we can see that this is an autofill. When you press enter, you have the function name addition coming up automatically. Now this automatic filling is very useful. Let's say we have add1 with this. Now every variable and every function that was declared under namespace add1 will be listed in this column. It will be listed over here, but in this case we just have one function. If you have two functions, they will be listed, and you can select from the drop down list that would appear. Over here we just have addition. So we press enter, and now we have this, and we have to enter int a and int b as this line of text is specifying. So let's just enter any int and then int 6 with a semicolon. Right. So we can just go ahead and print this explicitly, or we can store this in a variable. We can store this in a variable and say int a, int x or c, anything is equal to this. Then we come down and see out c. Right. So we run this and we should be getting 6 plus 3 is 9, and we have 9 returned over there. So that is how to call addition. Note that without this, if I just call addition, right? If I just call addition, we get an error over here that addition was not declared in this code because we have put it under a namespace. And why we put it under a namespace is because we have two functions called addition, and we have them accepting the same parameters, but then we still want to keep them under the same name. And so how do we want to override this limitation? By using the namespace. So let's run this again. Remember, you start with the namespace with two semicolons and then the name of the function. Right. So let's just go ahead, let's clear this, and then just explicitly output this as cout with that. And then we want to put this over here, endl, and we want to output the second one. We want to call add2 and with two semicolons, and it's also containing the function addition. But then let's add 5 and 7. We want to end line over here, and we want to run it. So we run it. Right. So we have 5.7 over here. Right. 15.7 as this particular one. So let's see what that function is doing. Right. So what that function is doing is it's taking wait a minute, let me just put functionality for the b as well. So this will multiply a by b and then times pi, right? Because you are entering two parameters, we want to use all of them, right? So we will take int a, int b, and we want to return a times b times pi over here, right? And pi is 3.14. So let's go ahead and then we want to close this, or since it's addition, let's just add it, not multiply, so that it would coincide with the name of the function. So in this particular one, we want to add pi to it, but in this particular one, we don't want to add pi to it. And we know that pi is a double, and we want to return a double result and not an integer result over here. But then we want to use the same function name. So this functionality will allow us to do that. So let's quickly run this. We have 9, that was 3 plus 6, and we have 9, and we have was it 5 and 7. So over here we have 5 plus 7 plus pi, and we have 15.14, right? So now we can use the same function name like this by using the namespace. Remember previously we couldn't do it because the parameters were the same, they were the same numbers, they had the same numbers, and they were the same, or they were of the same data type, right? But now we can do it easily. One other thing I would like us to look at is calling the constant pi. And we know that we can't call variables which are local, we can't call them globally. Now we have pi declared under this function. Can we call it outside of it? Let's try it. So we have, I think I should just clear this, right? So we have cout, and the format is cout. It's under @2, so we say @2 semicolon pi, and we can see over here that it's not accessible, right? From the drop down menu over here, it's not accessible. We can only access the function. When we still continue to do that, we are going to get an error. So let's just run it and see what the output is going to be. So we get an error here saying that pi is not a member of @2. So how do we make it a member of @2? Over here, it's a member of double addition. So we want to cut this and paste it in here so that it will be a member of @2 and it will still be accessible to addition. Remember, all of these are members of @2, right? Now, this one is under double addition, so these ones can only be accessed inside double addition. But inside the name @2, we have another seemingly global variable inside @2. So any block of code inside @2 can access the variable pi. So if we had a second function here, we can use pi as well inside its code like this. So let's go ahead and try to run any output with this to see whether pi can be accessed by double addition. So let's just clear this and we will run this line again, but let's just comment it out and then try to do this first. So we want to see if indeed it was accessed by addition. So we want to print add, and I think it's @2, right? @2 with 2, and whoops, now we can see the pi constant over here, meaning it is accessible now to @2 and addition. So let's just go ahead and input two parameters. We had 5 and let's say 6, 5 and 6, right? With a semicolon over there. Let's put an end line in there. Let's just run this to see what the output is going to be, right? So we have a result over here. So any function under @2 can access pi as well, but any function that we have under @2 cannot access the int a over here. You can't access it because it's a local variable, because it's declared under this particular block, right? So now let's go ahead and see if we can access it, if we can access constant double pi. In this case, it is declared as a seemingly global variable under @2. So let's try to access it. I've said that line severally, probably you might be tired of it by now. So we clear all this and then we just have to, so how do we access it? We can use the @2, the name of the namespace is @2 with the two columns, and now we can see that it is accessible over here. So all we have to do is to enter, and then we have a semicolon over there. So we can create a variable to store this and print the variable, or we can just explicitly run this on the go. So we run this and we should be getting the value of pi as 3.14. Right now it's being accessible as 3.14. Good. So that is how to access variables using the namespace as well, when you group things under the namespace. So we see if we have left any other thing to talk about. So namespace can be split, right? So let's say that I want to, let's say this is on the 17th line over here that I declared namespace add to. Let's say on the 100 and, well, let's even come down here, right? Let's come down here, right? I got here and I wanted to add a certain element to namespace add to. What do? I can just call it namespace add2. That is the namespace that I want to add the variable to. So I can just say int, the first one was int pi. Let's create a constant e is equal to, I think it's 1.6 times 10 to the power negative 19. Right, so let's just say that this is a constant e, and now it's under the namespace add2. You don't need to come back to wherever that you had declared it to put it in there. You can just call it on the go and then input whatever functionality that you want. So let's say that I want to print out this. We can have cout and we have add2, and with these two semicolons, and you can see that the e has appeared here as well. So that means it's accessible, and we can just tap it and have that, and we can print it on the go. So let's go ahead and just run this to be sure of what we are doing. So I want to use the tab over here. I don't want to, right? So we run this. Whoops, I have an illegal, what? Constant double. Sorry about that. So it's a double, constant double e. Let's clear this. We run this. And now we have this one accessible as well. So that's how to add functionality. That's how to add variables to namespaces on the go. So I just cut this and then paste it under here. So we still have a lot to talk about. So the next thing we want to talk about is using this keyword using. Now, what using allows us to do is it makes calling entities under namespace a lot way easier. So how do we apply it? I think the best way to explain it is by using an example. So I'll just use the example that we had previously. So I copied and pasted these two examples, and the other ones will be using. So we have namespace add1, and we have constant. We have added more functionality to this one. We have a constant double pi over here, and we have a constant double pi here over here as well. And they're storing the same values, or we can even change it to a different value like this, right? So same variable, but with different values. This one is called pi. This one is pi as well. Remember, if you were declaring these globally, you couldn't have used the same name. You can't do it. How then do we use the using namespace to call out these ones? I'll go ahead and clear out all this. And you have to use the keyword using. But first, let me just write out this functionality. If I want to access the pi constant and add1, what I have to do is I have to do this add1, and then with these two semicolons, columns, and we have the constant pi accessible over here. Now, this is the normal format of doing it. So I can store this under a variable and then print it out, or I can just print it out explicitly, right? That is the normal way of doing it. But then we can use the keyword using before it, right? That is the only way. You just using add two colons pi, and then you can then call the name as before, like normally as before. So we can just call pi and then print it, or we can just cout pi directly without having to go through the normal long way, right? So we can just print out pi directly. So let's run this, and we have an error over here. It says red definition of int add1. Okay, so I have to comment out this because it says that I can't have them like that. So now we go ahead and run this, and now we have the pi and the add accessible to us. So we have 3.14 over here, right? So let's check that again. So we have a constant variable 3.14 under the namespace add1 over here, and then using the using keyword. The normal way is to use add1 double colons pi to be able to access it, but with using this keyword we can just keep using pi pi pi. So let's say that I want to use pi again over here, then what we can do is we can just use pi times, let's say times 3, right? We can just do this other than having to say cout add 1 2 semicolons pi then times 3, other than having to write this long sequence of characters. With this line over here we can just be using pi pi throughout, so you might not see the great functionality or the great easiness it provides right now, but when you're writing a very big program and you want to be using this variable, then you can't be writing add 1 with 2 semicolons with pi every time. So you might want to kind of make the work easy. So that is the functionality the using keyword provides as well. And we can see even more functionality as we move on in this tutorial. So I'll go ahead and close this, and we're over here. So the using keyword can be used to introduce an entire directive. Now you might have noticed that I think at the onset of this series of these tutorials, we were using when we wanted to print, you have to output std two colons with cout, and you have your block of code whatever here, so you can have a hello or anything over here with a semicolon, right? This was what we had to do. We had to use std standard character output like this, but then with the addition of this line, so you can see the connection here now. With the addition of this line using namespace std, so this is std is the name of a particular namespace that was created for the C++ language. So when you use this line using namespace std, you don't have to keep calling it. Just like if we want to access a character under add, we have to use add1 with 2 semicolons before we can access this pi constant and before we can do anything with it, right? But with using namespace std, it allows us to clear out all of these so that we can just explicitly just run this line of code and with no error. So what this provides us is that the functionality it provides us is that, and you might have seen the connection already. We can just say using namespace add, let's say add1, right? Using namespace add1, then every entity under add1 can be called on the go without necessarily having to do add1 with 2 semicolons pi. So we don't need to do this. We can just, so let me just comment this out and then just comment this, clear this, and then just run this explicitly. So let's run this line of code, and now we have 3.14 returned, right? So let's say that I want to print cout, and with I can just call addition, right? I think it's add, and then I have 3 and 4. The normal way is to use add1 and with 2 semicolons with addition, and I will have my 2 parameters 3 and 4. But that is not what I want to do. What I want to do is I use this keyword over here, so it allows me that functionality to just call addition, right, with 2 parameters 3 and 4, 3 and 5, and it's going to run perfectly. So let's run this, but before that let's just add an end line over here so we don't get a clash emdl. So we run this, and now we get an 8 over here. So what this add1, oops, where is it? So what this add1 does is it takes 2 parameters a and b and it adds them. So we have over here 3 and 5, and it was added. We didn't need to go through this long procedure as we did before because we have used this line over here, right? Now I want to show you guys something. So let's say that we have a double pi over here and we have a double pi over here. 2 variables, different variables with the same name, right? Good. Now what happens if I come to use the using namespace, right? using namespace add two over here, right? And then let me add that semicolon over there, and then I come out to print pi again, because we have pi under all of them, so they should be accessible. What happens if I do this? So let's run this to see what will happen. And now I have error message over here, says reference to pi is ambiguous. Right. So what we just did is we have returned to square one, because when we using namespace here, it allows us to do what we want to do normally by calling out the variables using their names and on the go like that. So we have pi here and we have pi here. So even if I ask you which of these pi's is which is which, so you might even be confused as well, because they are all pi's, like pi here, pi here. There is no really difference in their names. So this is too ambiguous for the program. So what we can do to be able to access these is we can group them under two groups of code, right? So what I just did is, let me clear this again and then do it again for you guys to see. So what I just did is I am creating two blocks, right? Right. I'm going to create two blocks and then put the code in there. So we have the first block over here, and I'm cutting all of this and I'm putting it in here. Then I create a second block, right? I create a second block over here, and then I copy all of this code. Let me just cut it, and then I paste it in here. So now we have two explicit blocks. With this difference, then we can access this pi here and we can access this pi here as well. So let's run this and then to see what we'll have. We still have an error here. It says that unexpected or unqualified before that. So what did we need to do? Okay, so after the void, I needed a opening bracket over there. I mistakenly cleared it. So we are now inside the void function. So we run this. So we have the first pi, which is 3.14, and we have the second pi, which is, wait a minute, this line is joined over there. So we don't want to join them on an end line over there. So we rerun this. Let me close this first, and then we rerun it. So we have the first pi as 3.14, and we have the addition output over here as 8, and we have the third pi as 4.3 whatever. So let's go back here and check. So we have this pi over here, that's under the add2 as 4.37 and all of that, and this is returned as an exponent to be able to represent it. And then we have the first pi as well accessible. So that's how to access two variables with the same name and two different namespaces, right? So we go ahead and close this and want to see the next thing to look at. Next thing I want to look at is use different blocks to be able to use, okay, we've done this one as well, and namespace aliasing, right? So the next thing I want to look at is this concept, namespace aliasing. So what if I get to a particular point in my code and I don't want to use the namespace add one. I want to change it because it does not really come along with that section of the code. Maybe that section of the code I'm doing a different whole lot of functionality, so I might want to alias it. So what I can do over here is I can write out namespace, and the new name is that, right? So I just want to say new name over there, and I am equating the new name to the current name. That was the old name, that is add one over there with a semicolon. So now if I need to call add one, I need to use the new name. Let me just clear this and say add. So the new name is now add one. I'm cutting it and I'm pasting it in here. And let's say that I want to print it out. Let me just print it out. Right. So we run this, and where is it? Yeah, it's printed as 3.14, but because we did not put an end line over there, let's just put an end line so we don't mix up things over here. So I put an end line. Right. So I rerun this, right, and we have the 3.14 returned over here because we have aliased it, right? So that is aliasing in namespacing. So we want to look at the next section, which is storage classes, and that's going to be the last thing we are looking at, and this is quite theoretical, right? So storage access. Now when you declare a global variable, because the variable is going to be used everywhere in the code, because it should be accessible everywhere in the code, what the computer does is it creates a portion of memory called the static memory for that particular variable, because you want to keep it in a room that you can always access it. But when you call a local variable instead under a function, under a loop, or under a namespace, whatever, when you create a local variable, then what the computer does is it creates an automatic storage for that particular variable, because that particular variable is not going to be accessed by every portion of the code. So when the program runs to a particular line, let's say it runs to this line, and we have to use the function addition, then it creates an automatic memory for every local variable that is over here, right? So after that execution and it moves on to the next line, then that memory will no longer exist. That automatic memory would no longer exist for those local variables. It would be used by, let's say we come here and we want to declare add2. It will be used by the functions and the local variables under add2. So it creates an automatic memory for that one. And after execution, it does no longer, that automatic memory will no longer belong to those local variables, but it will belong to other local variables of other functions depending on when those functions will be called. But for the global ones, a permanent storage is created for them called the static storage, and it will be accessible everywhere within the code. Right, so that's it for the storage class as well. And what we've looked at over here, if there is anything that you should take away from this video, is the using namespace with the identifier, right? So how to do that, and the limitation that we have just overridden if we want to use same function names with same parameter types and same number of parameters that the overloading does not provide us. Right, so that's it, and hope to see you in the next video. Stay safe.